right, it's time. So let's get this started. Good morning, everyone. My name is Willem-Jan Glerum. I'm from the Netherlands and work for Lunatech. It's a software consultancy company based in Rotterdam, the Netherlands. And we're here today to talk about single sign-on made easy with Quarkus OIDC. Dirk did a presentation yesterday introducing Quarkus. And I'm interested to hear, has anyone else here used Quarkus before? No Quarkus users, only a few? All right. Then I'll also show you some of the basics so you have an idea what it's like, what it does. Today's agenda, why single sign-on? What is OIDC? What are all these abbreviations? I'll help you with that as well. We're going to have a look at ID tokens versus access tokens, when to use them, when not to use them. Then we're going to dive right into the code to see how to use Quarkus OIDC. We're going to have a look how this works in dev mode with dev services. We're going to do some testing, continuous testing as well. And in the end, I'll show you what to do to go to production. So who has built their own user registration system before, or user database? Was that nice? Was that easy? People really don't like it. I mean, most of the times you want to focus on building functionality, deliver value for your customers or for your users. And doing this entire login system, registration system is complex and tedious to get it all right, especially nowadays with the MFA, of the hardware tokens with YubiKeys, etc., etc. And that makes it really hard to use. Next to that, most users don't want to create yet another account. Especially if you're in a company, you want to make sure that the people logging in use just one account and don't have like 25 or maybe 200 accounts to log into every system. But it also goes for your peers who are not so technical. They probably don't want to keep track of all those registrations, logins, and all those passwords because they probably just reuse the same password with their birth year or whatever birth date in there. And keep on reusing that. I mean, we know how to use a password manager, but most other people don't really do this. The next thing for enterprises, a good thing most of the times is having roles and rights in one place. It's a term that we hear a lot. It's called RBAC, role-based access control. You can define centrally which roles a person has, and you don't have to go in every other system. Should I make this guy an admin or a finance person? But you can manage that more in a central way. Some key examples are Azure Entra ID nowadays, Okta, Google, or you host it yourself with Keycloak. And there are many more providers, self-hosted, or on the big cloud providers that provide this for you. A lot of times if you try to sign into a website, you see those buttons with social login, you log in with Instagram, Facebook, Twitter, GitHub, you name it, all works with single sign-on. So we covered the first bits. SSO is single sign-on, and how do we provide that? Traditional web apps could use SAML, for example. That's quite complex with XML. It's hard to understand and nobody really knows how it works. But if it works, it's nice. Instead, they came up with OpenID Connect. It's not the same as OpenID. You also have the OpenID standard, so it's also XML-based, but this is OpenID Connect, all with REST endpoints and JSON configuration. It's an open authentication protocol, and it basically extends OAuth 2 with an identity layer. So on OAuth, we had an access token. With OpenID Connect, we can also have an ID token to see who the user actually is. So today we don't have a lot of time, so I'll dive into some code as well. We're only 5 minutes in, and this could be basically the presentation. Short introduction to single sign-on, you add the Quarkus extension, you're done. And I'll actually show you how easy it is to get started, so you didn't come here for nothing. So here we have a code.quarkus.io. It's basically something like Spring Initializer as well. You go on the website and you find yourself some extensions. We want to make a simple REST application. We want to have the OIDC Connect plugin. And let's add the Swagger UI as well. So we can inspect our endpoints. And there are many, many more extensions, literally hundreds of extensions out there. It lets you download a zip of the application. Let's unpack it real quick. And then I'll show you what's in there. So what we get is a nice sample application with actually some sample code in there as well. Basically sets some versions, sets the Quarkus one and the extensions that we configured there as well. We didn't do anything else. Then we simply have one resource that says hello. So basic hello world example. What I always like to show, the application properties is what you use to configure your application. In this case, it's empty. It doesn't provide you anything. If I now start this application, you can also start it with the Quarkus CLI, with Maven or Gradle, just depending on your build too. But for this demo, it's nice to do it inside IntelliJ. What you see happening directly, it's starting here, but it's also in the background starting a Docker container for me with dev services. So it detected that we had the OIDC extension in there. So it's like, well, I need an OIDC provider. My configuration is empty. Then it uses convention over configuration. So like, well, then in dev mode, I'm going to provide you with a pre-configured Keycloak installation with some dummy users in there. And for good measure, because it's about security, it's Alice and Bob, of course. So let's have a look at this little application. It serves you a nice UI to see, well, what endpoints do we have? Well, we have an hello endpoint. And that's basically it, and the extensions that we already saw. If you now go in here, this is the dev mode. This is only available in dev mode. You don't have that in production. Here we can actually see our dev services. So here's our Keycloak container, and it injected for us some configuration. So normally, you would, if you would connect to your own Keycloak provider or Google or Microsoft, you would have to hand code this yourself, like get the secrets and the credentials and the URL. But in dev mode, we get everything for free. So that was a basic presentation. Before we dive a bit deeper, so we now saw a basic Quarkus application and we didn't use any authentication. We have the Keycloak provider, that's it. We'll start building it a bit further. Some abbreviations. In the software world, everything has abbreviations. Sometimes abbreviations are the same. People don't know what it actually means. Sometimes we have abbreviations of abbreviations that form a new word. That's what you see here happening as well. We have OpenID Connect. I talked about that one already. We have Open Authorization, OAuth. We have an IDP, the identity provider, so Keycloak in our case. Then we have JSON Web Tokens. Some people call them a JWT, some people call them a JOT. I don't know how you get JOT out of those letters, but that's what I thought of. So the tokens are as a JSON format. Then those tokens have a signature, the JSON Web Signature. And to sign your tokens to get that signature, you have a JSON Web Key. And normally you have multiple keys, so you have the JSON Web Key set. And then the other one, RBAC, we already discussed, the role-based access control. Typically, if you start developing applications, you get two flows. The OpenID Connect specification has a lot more flows. For example, service-to-service authentication. If you have an Android app or a local device that needs to connect, there are more and more flows for that as well. But for this presentation, we'll focus on the two most common ones that you use for web development. We have service applications. That's your traditional single-page applications. And they use bearer tokens for authentication. And you can also leverage for service-to-service communication. So you have microservices, your single-page front-end could use this token to send it to the first backend. And this backend could then forward the request to another service and use that same access token. Then we have web applications, and they use the authorization code flow. And they're great for server-side apps. So if you use server-side rendering, your classical web app, then it's mostly what you use. So how does this look like? So if we have bearer token, we have a Quarkus user. He tries to access the single-page application. And we already assume he is authenticated. So we have this, So it uses the flow in the backend to authenticate. Then the Quarkus server has already got the JSON key sets from the OpenID Connect provider to be able to verify this access token and that can talk to each other. If you then compare that to the code authorization flow, that's a bit more complex. You see a lot more steps involved here. So if the Quarkus application gets to, a Quarkus user gets to your application, it detects you're not logged in yet or your session expired, it will redirect you to the OpenID Connect provider, to the authorization endpoint. The OpenID Connect provider might prompt you to log in again. Maybe you're already logged in, but your session expires or you have to re-log in. The user enters his credentials, does his MFA, and then he gets back redirected with an authorization code. So the OpenID Connect provider generates his authorization code. Then the user goes back to the web app, he's redirected, and he uses this token, this authorization code, to exchange it for the token. So in the backend, we'll use the client credentials together with the authorization code to get the actual ID token, access token, and refresh tokens. And an optional step that we see here is we can use that generated access token to get a bit more user info, because those JWTs are limited in size, because otherwise you can't store them in your session. So sometimes if you want to get some more information about the user, get the profile picture, get some other data, you can call this user info endpoint. And in the end, a session is created, and the session can be refreshed in between as well. So we have two different tokens. We end up with an ID token, and that mainly tells you the user has been authenticated. So you know who that person is, and it might contain some metadata, the email, etc. In that token as well. So what can we do with this token? We can assume the user is authenticated and get some profile data from this token as well. What we shouldn't do with those tokens typically is use them to call another API. That's why we have the access tokens. And we also shouldn't check user access either. You could use it in a single application to display maybe the roles that the user has. So for information, if you actually call the backend, you use the access token, and then you verify the claims if the user can really access this endpoint. So that's what we see here. With the access token, that the application has been authorized. The specification is from OAuth, and with this one you can call another API, check the user access. What you typically shouldn't do yourself is inspect that token. If you use Keycloak, for example, you could, because it's simple as JWT. But if you use run, for example, on Azure or some other providers, it might be an opaque access token. So it's literally a random string of gibberish, and only the Azure backend can inspect the token. And what they then mostly provide to you is a token introspection endpoint, so you can send off the access token back to Azure, and it will tell you like this token is still valid for X minutes. So those JWTs, they have 3 elements. So if we go and inspect the token, It still looks like gibberish, but it's base 64 JSON, so we can decode that. And the red bit is basically the metadata, the header, so it tells you which algorithm we use to sign this token, what type is it, well, it's a JWT, and the key ID, so which key was used to sign this token. Then we have the actual payload, the actual content, the green bit. Shows you a lot of fields in there, when it expires, when it was created, who was the issuer, and who's the audience. And will contain a bit more information as well. You can have, there's some common claims, but you can also have your custom claims in those tokens as well. Then we have the blue bit, and that's the signature. This uses private key with public keys to sign these JWTs. Because you could imagine it's like, well, this guy's an admin, but that you could just change it to finance and then change my token. Well, back in the days with the script kiddies, you could actually do that indeed if it was not well protected. But with JWTs you can't because we have the signature. So if I would change this content, I can't generate a new secret because only the IDP has the keys to generate this one. If I then get such a token, so I'm an application, I get this token, I first can check the signature, so that I use the public keys from the IDP to verify if this matches. And the nice thing is, I only get those keys once, and I can verify a lot of tokens. Back in the days, you also had systems where you got a token, you had to send it to the provider. For every request, you had to go check if it was still valid. With this one, you can do that out of band, and just can check it yourself. The next thing that you should check, if you get a token like this as a server, is to see, was this token made for me? And was it issued by the right party? So we can see the issuer, well in this case it's localhost because it's from an example. And the audience is Quarkus application. Now the audience will be Spring application, you would reject it because the token was not made for you. Maybe it was a bogus token or a malicious token, not meant for you. Maybe the claims that are in there with the groups don't make sense at all for your application, so you can't use it. So if we now go back to the example, we can see that we have this keycloak provider in dev mode, and then we can also log in as a single page application. So what I could do is log in, I get redirected to keycloak, my IDP, I log in as Alice, I sign in. Of course, Chrome detects that it's not a good password because it's just Alice. And here we can do the same inspection to see what's in those tokens. So that's really great in dev mode. You can provide you some dummy users, and then you can play around with those dummy users in your application. Well, the basic example has Alice and Bob configured for you, but you could also use the application properties configuration file to create more users that maybe you have some personas in your application that you want to use for testing. You can create those personas with their username, password, dummy users, and then give them some roles as well. The nice thing as well, what we can do with this one, is we can test the access, so we can make a request here. What I just found out the other week at DevOps Belgium, if you enable the Swagger UI, it has this little Swagger UI redirect, and then it logs you in, so it provides an open API endpoint with a Swagger UI, and automatically logs you in here as well. So I can now make requests here too. And then we see indeed, hello from Quarkus REST. So this is just one bit, this is just authentication. Quarkus uses proactive authentication, So if it's present there, it will prompt you to log in even if it's not required. If I now, for example, say a simple annotation, it's just a simple Jakarta annotation, roles allowed that we're probably all used to. And you say you need to be an admin to access this endpoint. What now will happen in the back, if I refresh this, it will automatically recompile and do the request again. Well, in this case, the login expired, so let me try another login with Bob. So if I try to log in here with Bob, so that does work. But if I try to access my hello endpoint, it will give you a 403 because Bob is just a user and not an admin. So are we sure about that? Let's have a look at the token. Yes, Bob is only a user, so he's not allowed to access this endpoint. What happens in the back as well, that we have continuous testing here. So that we can enable as well. That was the wrong window. So we already have dev mode running with a key cloak provider in dev mode. Owner can play around, log in as different users. I have the automatic hot reloading, so we change some code and I actually can try it and see it in action. Next to that, we also have continuous testing. What happened if I enabled continuous testing? It saw that also for testing, I didn't provide an OIDC URL or configuration, so it's empty. It's going to start up another Docker container just for my test and running my tests locally. So now I have two Docker instances running, one for dev mode, one for test, and it all happens in one window. So it's all together here. So in this case, this test fails. Let's see what it was about. So expected status code was 200, but it was actually a 401. Well, that's annoying because I need to be authenticated for this endpoint. And you can see this is a simple rest assured test where we say call this endpoint and verify if it's a 200. Well, what I could do for now is like, well, we expect a 401. Oh, then we get a bit further. So the response body doesn't match now, so we can play around. So like, well, and all tests are passing. It's probably not what you want to do, so I'm going to show you the proper fix. Let's revert this. For this, we can add another Quarkus test. As you can see, it nicely autocompletes, and we have some Quarkus test extensions here for different security scenarios. So we get a default one test security that does it basic security if you just have basic auth, but in our case we're using OIDC, so we can have this nice test extension. Let's reload, yes. And now Quarkus provides me with an annotation test security. And here I could just create my own user. And I'm not sure if it liked the reloading here. Let's try again. Because I added a new extension, something crashed, shouldn't happen, but yeah, we're at a demo, so stuff breaks. Let's try this again. Now we got our Docker container starting again. Something is going wrong. There's a dev UI in the background spamming on not authenticated requests, so that's why polluting my logs now here. So let's see. Resume testing. And it still failed. So expecting a 200, but now we got a 403. So we're now logged in, but I don't have the right permissions yet. So the test security annotation can do that as well. Say roles, make Willem an admin as well. And then we should see that the test now runs successful. So that's how simple it is. So for test, I don't even have to create the user in my configuration. I just say, hey, for this test scenario, this test case, annotate my test method and get me a dummy user there, just for this case. If you now have more custom claims that you want to test, there's more annotations that you can use. You can use the OIDC security annotation. Have a look what's in there. And there you can just pass it an array of random claims that you want to put in your token. So if you have more complex cases that you want to test than just the username and the roles, you can roll your own and put some more information in there as well. So this is what we saw. The Quarkus dev services automatically starts those Docker containers for you. Zero configuration, it just works. And we can define test users with configuration. And we of course have all those Quarkus joys of hot reloading. When you change something, you get it immediately. So we saw it for testing. We use for the dev services with Keycloak again with testing. And we have that continuous testing in dev mode. It makes it really nice. Well, to fix your test, make some more tests, try some stuff out in parallel in dev mode, change some more tests. And the nice thing is, even if you have a big test suite, Quarkus will do some smart detections to say like, hey, you only changed this bit of code, so then I only have to rerun these tests. Because can you imagine if you have a big application, then you don't want to run all hundreds or thousands of tests again, but just the one impacting your change. So now we've done locally, done some development, did some testing, had quite some fun developing this as well with all the hot reloading and everything being set up for you automatically. Imagine setting up an IDP yourself, setting up a testing for Keycloak, configuring all the realms. That's quite complicated, and Quarkus all took that for us away and provides it automatically. If you want, you can of course still do everything yourself and tweak it on your needs. When we now go to production, we have some common providers. So if you're on Azure, you use Microsoft Entra ID. Some people use GitHub, or you use your own Keycloak. What you can do, instead of... so some OIDC providers are quite complex. They need a bit more configuration. So instead of specifying all that configuration, you can just say like, hey, my OIDC provider is Microsoft. And then Quarkus has some preset configuration for you already that fixes the quirks that all the different OIDC providers have for you. And I think they do the most common ones like Microsoft, Google, Twitter, Apple, GitHub, because they all need some kind of slightly different configuration. And it's really hard to get it right, because then you're happy, like, now it works in dev mode and testing, but now we go to production and you forget something and then it doesn't work. So they help you to configure it as well. What else can you do? You can have multi-tenancy in production as well. Imagine building a SaaS app for the different customers. You can have a multi-tenant application as well, where you configure multiple OIDC providers for the same application. And what you see a lot as well, what we do at Lunatech as well, is user federation. So our main users are in Google. In between, we have a Keycloak instance for applications, because some applications don't support the Google login. Then we federate them from Google to Keycloak and let the users sign in like that. So that's how you can get, maybe if you have your users in a legacy LDAP system somewhere, hook it up to a Keycloak, and all of a sudden you have a modern single sign-on solution. All right, so this was a short overview of what is OIDC, how do I provide single sign-on, and how easy it is to get started developing these kinds of applications. So I hope you learned something, and if there's any questions, let me know. Any questions? So the question is, if I generate this application on code.quarkus.io, can I make it micro-profile compatible by default? I would not know. You would also have to ask the Quarkus people or the Red Hat people for that. Yeah. Go ahead. So the question is, what about SAML? How to integrate that? Then I would go via federation, for example. So you have a modern cloud-native application that does OIDC, and maybe then have something like Quarkus in between, or sorry, Keycloak in between, that does this federation and does that maybe in between. But that you just, your cloud-native application has an ID token and access tokens and doesn't have to deal with all the SAML requests. Any other questions? All right, then thank you all, and enjoy the rest of the conference.